In this video lesson, we explore common factors of polynomials and some of the language around polynomials. This is important for us because Chapter 3 requires us to factor not just values, but polynomial expressions, and common factoring is the simplest form of this task. In order to be successful with this lesson, you need to know what factoring is, in other words, undoing the multiplying to show what was being multiplied together. You need to know what expanding is, which is simply another way of asking you to multiply. And you need to know some basics for working with polynomials. In this example, we know that 2 multiplied by 5 is 10, and we know that x multiplied by x squared will be x cubed. When we discuss polynomials in this chapter, we have two forms that we will talk about. Expanded form is the form that has no brackets. You can't quite tell what the factors are. Factored form shows the factors. It does have brackets. So from our last slide, 2x multiplied by 5x squared is the factored form, and 10x cubed is the expanded form. In order to discuss common factors, it's helpful to remind ourselves about finding the greatest common factor of numbers. In this example, the greatest common factor of 32 and 48. And when we deal with common factors of polynomials, often there's not nearly as much work involved as we had with values. So we might think about 32 as 2 groups of 16, and 48 as 3 groups of 16, so that the greatest common factor would be 16. And of course, we've learned earlier on in this chapter how we could use prime factorization to also find the greatest common factor of 2 to the power of 4, or 16. In this lesson now, we're starting to work with polynomials. A polynomial is an expression that involves one or more terms, typically with variables. And we talk about different types of polynomials. A monomial has one term. So for example, x or 12y or 17n to the power of 4. A binomial has two terms. So for example, x squared subtract 4, or a plus b squared, or m to the power of 10 adding 7n to the power of 5. A trinomial then has, you guessed it, 3 terms. For example, x squared adding 5x subtracting 14. If you need to, hit pause so that you can write down the definitions for these vocabulary terms. When we're dealing with the common factor for polynomials, it's simply a case of finding the greatest common factor. In this first example, the greatest common factor of 3g and 6, well, we can think about 3g. 3 is a prime number, and that's multiplied by g. 6 can be factored as 2 multiplied by 3. The greatest common factor in this case is 3. In factored form, we'd talk about 3 multiplied by g and multiplied by a positive 2. So our greatest common factor is 3, and the leftover pieces that would multiply to produce 3g plus 6 are the terms in brackets, a monomial and a binomial. In this second example, we can think of 8d as 4 multiplied by 2 multiplied by d plus 12d squared, 4 multiplied by 3 multiplied by d multiplied by d. Looking for the common factors, each term involves multiplying by 4 and multiplying by d. So we will factor out 4d and the leftover pieces 2 plus 3d. Now this is a good time to point out, this work is helpful to write down at first, but it would be totally acceptable to simply write down your factored form on a quiz or a test. Why don't you take a moment now to see if you can find the greatest common factor for this trinomial. If it helps, here's the full factored form. And we have a greatest common factor of 6z. Writing the factored form with the brackets is pretty straightforward, but becomes a little bit challenging with this first term. What are we multiplying with 6z in order to create 6z? Well, we must be multiplying by a 1. And so here is our fully factored version. As one last example, try factoring this one. Here's a helpful factorization. Now let's find the common factor. We can tell that we have a common factor of 5 times c times d. The first term leaves us with 3 c's multiplied together, 4c cubed. The second term leaves us with a negative 6 multiplied by 2 c's, or c squared, and multiplied by a d. The last term leaves us with simply a positive 5.